In this paper, we propose a new algorithm to control the formation and movement of crowd in real time using the deformable mesh. We define 3 types of gestures that give different levels of control over a mesh. The user can deform a selected area on the mesh, a varying number of lines, or even individual points using a multi-touch device. Traditional formation control constrains the relative order of the characters throughout the simulation. When interacting with the environment, the characters may not be able to maintain this order and reach their goals. We allow the characters to dynamically reassign their goals in the formation. This allows the characters to follow the mesh effectively even when perturbed by external obstacles. Here we show the experiments created by our system. The user controls a crowd to pass through a gateway while simultaneously changing the formation. Here we rendered the previous scene with humanoid characters. Notice that the mesh is deformed automatically based on the environment, such that the user can focus on high-level formation controls. This is another experiment using the same gateway environment. The user creates a Pac-Man formation by bending the 2 ends of the mesh towards the middle. In this experiment, the user controls the crowd to pass through woodland. The trees are modelled with small obstacles. The potential fields generated by the obstacles deform the mesh as it moves. Here is the rendered scene. Notice that the crowd maintains the formation based on the user gesture while moving through the woodland. We can specify different gestures to create a different scene in the same woodland environment. Here, the user changes the formation of the crowd throughout the gesture to achieve a final arrow shape. This experiment shows how the mesh deforms with dynamically moving obstacles. Because of this, once the obstacles have passed, the mesh returns to its original formation specified by the user. The crowd from the previous scene can be used to generate a lifelike scenario, such as people avoiding moving cars. Here, the user spreads the moving crowd to avoid the cars. In this experiment, there are multiple paths that the crowd could follow. Using a simple gesture, the user can define where and how the crowd passes through the pathways. Here is the rendered scene. Notice that even if the user does not explicitly specify the movement of individual characters, they fit into different pathways automatically. With a slightly different gesture, the crowd is split into different proportions. The user changes the formation into a 4-point star after passing through the pathways. In this scenario, one pathway is blocked. The user squeezes the whole crowd into one pathway. This can be easily achieved using the manipulation framework by stretching the crowd. The user changes the formation into an L shape after the movement. Finally, we show a complex scene with many environment obstacles.